Okay, SQL injection. There's some really cool videos on SQL injection on YouTube that I recommend if you want to check them out. We're going to talk about what is structured query language, because almost all databases today are relational databases, and almost all of them use the same standard SQL as the way in which you do the programming. But this was not always the case. There were databases which were non-relational. There were network databases, hierarchical databases, and then there were just simply file structures that people used to use before there were databases. Before there were databases, there were flat files and sequential access method files, right? Indexed files. That's what gives rise to those. Have you ever seen the names like ISAM and VSAM, index sequential access methods? What they did is they built keys into files so that they then went and they hashed the keys, and you could go directly into a file of either fixed or variable length records. Then they started to build databases, but initially they were just built upon those other key types, right? Random access files, keyed files, etc. When they first came up with the concept for relational databases, it was a person named C.J. Codd. Codd invented the relational database while he was at IBM. Now there's a few major relational databases out there, right? DB2, whose database is that? Right? Oracle, world's biggest, most massive, production-oriented database. But SQL Server is getting up there. There's a lot of SQL Server. It's not, usually they are not as large as Oracle databases, but they can become quite large these days. And then you've got MySQL, Postgres, and several other databases, Sybase, Informix. There's some databases that are actually non-relational. There's some that are built in with fourth-generation languages. And Access is a flat file database, right, that supports relational syntax. Stands for structured query language, allows us to access the database. The database is composed of records, right, that are in relationship to each other. We can have different sets. So we have a schema. What's a schema?
Schematic layout.
What tables are in the database? Those tables then have records. Records are composed of what? Fields, right? Those fields are the columns within the record. We think of them as the columns in the database, right, if you've got a two-dimensional database. And what are the rows? The rows are the records, right? Rows a record, column is a field within the record, right? And you can stack them all together. And they make a table, right? And you can have multiple tables. And then there's relationships between the records in the different tables pointing to each other. You can have an employee that points to a supervisor that points to, whatever, in your HR tables. So SQL is now a standard ANSI and ISO query language, right, known as SQL 99. Some of the things you can do in SQL, you can actually do lookups, right? Record retrieval, that's one of the most common things in database. You can also write to a database, right? You can insert records, you can delete records, you can update records. You can also create new tables in the schema. Oftentimes, in an Oracle database, only the database administrators can create new tables in the schema, right? The end users don't have those rights and permissions. SQL is a standard, but Oracle SQL is slightly different than Microsoft SQL Server, slightly different than MySQL. So they all have select statements, they have, where statements, etc. I don't want to do a Java update at this time. Thank you. Right? They all support select, update, in place, insert, delete, where, and other clauses. But then they, of course, add all their proprietary extensions to it. So what are in those proprietary extensions? Microsoft has a bunch that start with XP underscore, and it's not meant to be part of Windows XP. What does XP stand for? External procedure, right? These are stored procedures that are from Microsoft. So they have one called XP underscore exec, right, which executes commands in the operating system. Oracle also provides for stored procedures which reside in the database and allow you to execute things. So this is a table, right? Relational database contain one or more tables identified by a name. You can think of those as like an Excel spreadsheet inside the database, right? And it's just one sheet of a worksheet, right? Table contains records, also known as rows, with data, and then the data contains fields. So for example, the following table is called users and contains data in rows and columns. How many records do I have? And those records have how many fields? 5, right? There's 5 fields. Then there would be field names, right? Record numbers. So record number 1 would be this one if we're reading them sequentially going in order of the user ID. So if they were ordered or sorted by user ID, right, this would be record number 1, record number 2. And some of these fields can be made into keys so that you can do keyed lookup on it. You can do lookup on almost any field. But for really fast lookup, you should turn that field into a key. What does the key mean? Right, so if our primary key was user ID, we would be looking up these records by the user ID, right? 1, 2, 3, 4, whatever, right? Sometimes you can also search these records and look them up by these other fields, but it's much slower if they haven't been made into keys. It may reduce to as much as like sequential search of the records in order to do that if you haven't built a key file, an indexed file for it. Here's a typical SQL query, right? So we go against that previous database and we say select last name. So we're looking for records from users where ID equals 1. Who was ID 1? It was John, right? And that gives us this. What we're looking for is last name, so we get Smith. Now we can actually pull out multiple fields from the record or get the whole record if we want to as well, right? So this is SQL's data manipulation language so that we can write, we can update, we can insert, we can delete. Select extracts the data, update, updates it, insert into creates a new record. For example, and delete will be used to delete them. These are very powerful though because you can manipulate multiple records simultaneously. You're not limited to record at a time. There's a data definition language which is used to build different attributes. So if I want to build indexes, and indexes really are files of keys for fast lookup, I can index a field. I'm making a space-time trade-off because I actually have to then go and store that key file somewhere, right, with all those indices in it. But it means I can do things really bad. So on those things you want to optimize record lookup for, you're willing to spend the disk space to build and keep updated those key fields, right? You can also specify the links and the relationships between tables so that if I look up something in one record, I can then link to other records through that. And you can impose constraints between the tables. Some of the most commonly used data definition language statements in SQL are create a table. This builds a whole new spreadsheet inside the table. Alter the table so we want to modify it and then drop a table. You can delete an entire series of records containing fields.